This is Chapter 1 of Math 102, the first lecture we will go through. It is on inductive and deductive reasoning. Some of our objectives in this section of Chapter 1 are to understand and use inductive reasoning and understand and use deductive reasoning. Inductive reasoning is the process of arriving at a general conclusion based on observations of specific examples. Definitions. A conjecture hypothesis is the conclusion formed as a result of inductive reasoning which may or may not be true. And counterexample is a case for which the conjecture is not true, which proves the conjecture false. A strong inductive argument. In this example, it says in a random sample of 380,000 freshmen at 772 four-year colleges, 25% said they frequently came to class without completing readings or assignments. We can conclude that there is a 95% probability that between 24.84% and 25.25% of all college freshmen frequently come to class unprepared. This technique is called random sampling, which will be discussed in Chapter 12. Each member of the group has an equal chance of being chosen. We can make predictions based on a random sample of the entire population. A weak inductive argument. Neither my dad nor my boyfriend ever cried in front of me. Therefore, men have difficulty expressing their feelings. This conclusion is based on just two observations. This sample is neither random nor large enough to represent all men. That is why it is a weak inductive argument. Example 2a. Let's use inductive reasoning. We want to identify a pattern in each list of numbers and then use this pattern to find the next number. So if we look at A starts with the number 3. Let me get my pen ready. A starts with the number 3, and then it goes to the number 12. And then from 12, it goes to 21, to 30, to 39. Now, if we're trying to figure out how we're getting from one number to the next, we're trying to find some kind of pattern. An easy pattern here would be to add 9. 3 plus 9 is 12. 12 plus 9 is 21. 21 plus 9 is 30. 30 plus 9 is 39. Therefore, by inductive reasoning, we could reasonably assume that the next number here will be 39 plus 9, 39 plus 9, which would be 48. So, if we look at the solution, since the numbers are increasing relatively slowly, that's why we decided to use addition. The common difference between each pair of the numbers is 9. Therefore, if we do just like we did and add 9 to each, we get the next number. Following this inductive reasoning, the next number in this sequence is 39 plus 9, which is 48. Now, let's use inductive reasoning for part B. Here, we're going from 3 to 12, but now we are going from 12 to 48. And from 48 to 192, and from 192 to 768. So, we are no longer adding by a constant here. There is clearly something else going on. Since the numbers are increasing relatively quickly, we might try some form of multiplication. Well, what form of multiplication can we look at? Well, let's see. 3 times 4 is 12. So if we multiply 3 times 4, we get 12. Now, if we multiply 12 times 4, we get 48. Okay, we seem to have something that's working here. If we multiply 48 times 4, we get 192. Okay, I think we've got something that works. We multiply 192 times 4, we get 768. So using inductive reasoning, if we multiply 768 times 4, we should get our next number. Go ahead and try it on your own and see what we can get. So, following what we just did, just in a fancier format, we are multiplying by 4 each time. The common ratio between each pair of numbers is the 4. Thus, the next number, if you did your multiplication correct on your own, using either a handwritten method or a basic calculator, you could have gotten 4 times 768 is 3,072. So our answer here, if you multiplied correctly, would be 3,072 using inductive reasoning. What comes next in this list of numbers? We've got 1, 1, 2, 3, 5, 8, 13, 21. Now this is even more complex than the last, right? Because here we didn't add anything to get from the first number to the second number. It is literally the same thing. But then by the time we get to the third number, it does increase, and then it increases some more, but the increase gap here still isn't the same. So what is going on? The pattern is formed by adding the 2 previous numbers to get the next number. So let's look at this. 1 plus 1 is 2. Now 1 plus 2 is 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 5 is 13. 8 plus 13 is 21. So we have a different style pattern here. So if we look at this pattern here, 1, 1, 2, 3, 5, 8, 13, 21, we can tell the 2 is preceded by 1 and 1, which add together to be that number. The 3 is preceded by 1 and 2, which add together to be that number. And the whole process continues in our pattern. So the next number in this sequence we should be able to get by adding 13 and 21, if the sequence were to follow. Now 13 plus 21, we can do that. That is 34. If we've done this correctly, the next number in the sequence is 34 by inductive reasoning. Now, using inductive reasoning, we can in some cases come up with more than one solution. In this illusion, is this illusion a wine goblet or 2 faces looking at each other? Depending on how you look at it, you can clearly see that this is indeed a wine glass right here in the white. But you can also see how somebody could see this is 2 faces in the black facing each other. If we are looking at a numerical example here, 2, 4, and we are asked what is the next number in the sequence, we could get more than one solution. If the pattern is to add 2 in order to get to the next term, then obviously the next term in the sequence would be 6. But what if the pattern is multiplying by 2? 2 times 2 is 4, then 4 times 2 could be 8. So we would actually need another number in the sequence to really hone in on what this actual sequence is. That's why many times when we have these sequences, we have multiple numbers so we can see what's going on. So we can also do these sequencings with pictures. So we want to find the next picture in the visual sequence. Describe 2 patterns in this sequence of figures. Use the pattern to draw the next figure. The first pattern I'm going to look at is the dots. As we could tell, we have 3 dots here, 2 dots here, a dot here, and then at the next picture it looks like the 1 dot has risen here, the 2 dots have gone to the side, and the 3 dots have gone to the bottom. And then in the next picture, the 1 dot has moved another figure over to the left, the 2 dots have moved vertically up, and the 3 dots have also moved up. It kind of looks like a counterclockwise rotation in the dot figure. Now, if we expand out to look at the other pattern, we start with a circle, then we go to a square, to a circle, to a square. So using the basic outline here, we should easily be able to interpret that the next figure is a circle. Forgive how ugly my hand-drawn circle is. That is divided into 4 spaces. And by our first sequence here, if everything is rotating counterclockwise, the 1 dot should be here. Oops. The 2 dots should be here and here. Uh-oh. My clicker's acting up. Should have 3 dots here. I don't know why it keeps getting rid of that 1 dot. And there we should have what's reasonably our picture. Okay, so this slide just goes through the entire process we went through. It says its first pattern it's going to look at is the shapes. It's easy to interpret that the shape is a circle that we draw. The second pattern is the counterclockwise rotation of the dots. And as best as I could draw it in the previous slide, it's pretty much the same picture they have in this slide of what that next figure would be. Now, we've looked at inductive reasoning. Let's look at deductive reasoning. Deductive reasoning is the process of proving a specific conclusion from one or more general statements. A conclusion that is proved to be true by deductive reasoning is called a theorem. Theorems are very strong in mathematics. An example in everyday life. Here is your everyday situation. One player to another in a Scrabble game. You have to remove those 5 letters. You can't use Texas as a word. Deductive reasoning. Your general statement here is that all proper names are prohibited in Scrabble. Texas is a proper name, therefore you can easily conclude that Texas is prohibited in Scrabble. That is why in your everyday situation you were told you had to remove it. Let's use inductive and deductive reasoning. Using inductive reasoning, apply the rules to specific numbers. Do you see a pattern? Alright, select a number. We'll look at the first column here. We will select this 4. We will multiply the number by 6. In doing so, we get 24. We will then add 8 to that product. So to that 24 we just had, we are going to add 8. That's why we get 32. Now, we are going to take that sum and we're going to divide it by 2. So we're going to divide 32 by 2 and then get 16. And then from that, we are going to subtract 4 from that quotient being the 16. 16 minus 4 is 12. So we've gone through a whole process here. Now, if we use the number 7, we can do the same process. Here we multiply by 6, we get 42. We add 8, we get 50. We divide 50 by 2, we get 25. And then we do 25 minus 4 and get 21. The same process is also done over here to number 11. Okay, now using deductive reasoning, we can use n to represent any number that we can input in this situation. And we can follow these steps that they ask us to do right there in that chart. The first thing was select a number. Instead of selecting a number like 4, 7, or 11, we will use n as a placeholder for any number that we could decide to choose. Then we are going to multiply that number times 6. So 6n. 6n just means 6 times n, any number. Then we're going to add 8 to that. So now we have 6n plus 8. Now we're going to divide this sum by 2. Now, the general thing we get is 6n plus 8 over 2. But we can simplify this using fractions. So if we break this fraction up into 2 fractions, the 6n over 2 and the 8 over 2, we know that 6 divided by 2 is equal to 3. That is how we get the 3 here, from the 6n over 2. We divided 6 by 2, we got 3. And then here, 8 over 2 reduces to 4. So, using a reduction step here, we have turned 6n plus 8 over 2 into simply just 3n plus 4. Now, we want to subtract 4 from the quotient. So, in order to subtract 4 from the quotient, we are going to take this 3n plus 4 that we had from our previous step here, and we're going to subtract 4. Now, 4 minus 4 cancels itself out, and we are just left with our answer here, that is 3n. So 3 times any number is really the simplified process that we are using here. Don't believe me? Let's go back. We did all of these steps to get from 4 to 12. From 4 to 12, which was our final answer. 4 times 3 is 12. So, by simplifying our process and reducing, By writing that process out, we can see that 7 times 3 is 21. 11 times 3 is 33. So this process here of writing this out using deductive reasoning can actually simplify our overall process. This concludes our first lecture. Please go on My Math Lab and try the homework for Chapter 1.1. If you have any questions, do not hesitate to reach out and ask them to me via email. You are free to use a handheld calculator to help you with some of these small additions, multiplications, subtractions, and other things that you may need to do. But I encourage you to try to do most of your work by hand so you can get that extra practice in. Y'all have a good evening.